I've been asked to take a look at example 5 in lesson 1.2 and maybe give a little extra explanation, so I'm going to try and do that here. You can see I've sort of written the multiplication problem out here, but I've color-coded some things because that's kind of how we're going to attack this. We're going to look for some terms that have like bases and use our exponent rules to simplify this thing. So for example, I have an x squared term here, I have an x term here, and so in essence this x is going to divide one of these x's out. We're going to subtract exponents. I have a 2x squared plus 1 term here that's raised to the 1/2, and I have a 2x squared plus 1 term here that's actually raised to the first power, even though we usually don't write that first power down. And then we've got these x minus 1 terms, and even though there are no parentheses written on this one, it's implied that those are there. So we've kind of got a lot going on here. Notice this expression in black, the 4x cubed minus 6x squared plus x minus 2. That's its own cubic 4-term polynomial, and it doesn't have any factoring that we can do, so it's going to just remain in our result. So the idea is that we basically are going to just rearrange these terms because everything's multiplied together. This dot here is no different to the fact that these are next to than the fact that these are next to each other, or that down here at the bottom these three things are multiplied together. And so we can kind of use the commutative property and the associative property to rearrange these things. So what we'll do is we'll just kind of rewrite this. So the new fraction, when you multiply these together, might look like this. The x squared could be written over the x term, and then we'll subtract those exponents. Remember, this is x to the 1, and we'll just end up with an x when we're done. The green terms, which have 2x plus 1 as the base, can be written, ooh, that's a terrible looking half, can be written above each other, and we'll subtract those exponents. And then, like I said before, this 4x cubed polynomial is sort of all on its own. And then the blue x minus 1 terms, there are two of them, but they're both in the denominator, so we'll just multiply those together and add the exponents, and that makes it x minus 1 squared. So when they simplify this, the x squared over the x to the first, that's x to the positive 1, so that's going to stay in the numerator. The 2x plus 1 to the 1/2 over the 2x plus 1 to the first, when you subtract those, you end up with a negative 1/2. So that particular expression ends up in the denominator, and it's going to be raised to the 1/2 power. There's nothing to cancel with the 4x cubed minus 6x squared plus x minus 2, and likewise with the x minus 1 squared term. So that's another sort of way to look at how this expression was simplified. It looks like a multiplication problem, but really we're just simplifying, since everything in here is multiplication. So hopefully that sort of clarified what they did in the textbook. Let's move on to item B. So this problem is a little different than letter A. Here we're adding two expressions. And even though the second one doesn't look like a fraction, we can turn it into a fraction just by putting it over 1. And then to get a common denominator, we're going to multiply by a form of 1. In this case, since we want square root of x squared plus 3 to be our denominator, I'm going to multiply, 2x squared plus 3. I'll multiply the numerator and the denominator by that same value. I'm multiplying by a form of 1, basically. So you get a new addition problem. You get 12x squared over square root of 2x squared plus 3 plus the new fraction, which has the same denominator, because 1 times the square root of 2x squared plus 3 is just the square root of 2x squared plus 3. But in the numerator, we're going to have 6 times 2x squared plus 3 to the first power. Remember, a square root is like raising an expression to the 1/2 power. And so if both of these are raised to the 1/2 power, we simply add the exponents and we end up with the first power. You can also think of it as a square root of 2x squared plus 3 times the square root of 2x squared plus 3 ends up being 2x squared plus 3. So either think of it as radicals or of exponents. Either way, you end up with 2x squared plus 3 to the first power. And then you'll notice that we can distribute here. So I'll do 6 times 2x squared and 6 times 3. That'll give us 12x squared over square root of 2x squared plus 3 plus 12x squared plus 18 over the square root of 2x squared plus 3. And then when we add these fractions, we're going to combine like terms in the numerator, and we get 24x squared plus 18 over the square root of 2x squared plus 3. Well, I hope I made it better. I did a lot of similar things that the textbook did. I think maybe adding color might help you see how these match up, but feel free to continue to email if you need extra explanation on this. Good luck.